Dear students, before explaining the comparative statistics analysis of price change, income change, etc., we first consider a property of the demand functions, namely homogeneity. Homogeneity, a property of the demand function which we consider. Homogeneity can be explained in different ways. If we were to double all prices and income, that is, suppose that we multiply all the prices and income with a positive constant, then optimal quantities demanded remain unchanged. That is, if all the prices and income are doubled, quantity demanded will remain unchanged. It is known as the assumption of no money illusion. The assumption of no money illusion. If you double all the prices and income, only the units will change, not the real quantities of goods consumed. That is that is one definition of homogeneity. If prices and income are doubled, multiplied by a constant, a positive constant, say 2, quantities will remain unchanged. Graphically, this can be explained as a situation in which the budget line of the consumer will remain unchanged if you double both the prices and income. Consider this budget line y, x. This is I by py, this is I by px, the budget line. Now suppose that all the incomes, all income and all the prices are doubled, then you will get 2i by 2py and 2i by 2px, and here minus px by py is equal to minus 2px by minus 2px by 2py. That means the budget line is not affected. If this graph shows that if prices or income are doubled, multiplied by 2, multiplied by a positive constant, optimal quantity demanded, suppose that the optimal quantity demanded is given by, say, y star, x star, it will remain unchanged. And we will say that if the demand function of the consumer is homogeneous, as defined like this, then the consumer suffers from no money illusion. That is the graphic representation of homogeneity. Now, algebraically, we can write it as px into x plus py into y is equal to I. This can be written as 2px into x plus 2py into y is equal to 2i. Is equal to 2i. Multiplying px and py and income by I will give you, and this is equal to this, both are same. The same budget line, 2px into x plus py into y is equal to y, is same as 2px into x plus 2py into y is equal to to I. So both the constraints are identical. Now more technically, suppose that x star I is equal to xi p, I write it as p1, p2, etc. pn I is equal to xi I multiply all the prices p1, p2, pn and income with a constant. And if the optimum quantity is same, where t is greater than 0, this is the definition of homogeneity in technical terms. That is, x star I is a function of p1, p2, pn, etc. I is same as t into p1, t into p2, t into pn and t into y. That is multiplying all the prices and income with a constant t greater than 0, the demand for x is not affected. So functions that obey this property is known as homogeneous of degree 0 in all prices and income. Homogeneous of degree 0 in all prices and income. That is, if you change the prices and income in the same proportion, quantity demanded is not affected. Quantity demanded is not affected. Now this result shows that individual demand is not affected by what is known as a pure inflation. Individual demand is not affected by a pure inflation, where all the income, all the prices and income changes by the same proportion. But if the inflation is not pure inflation, that is, prices and income are not changing in the same proportion, you will not get such a result. So if there is pure inflation where income and prices are changing in the same proportion, quantity demanded is not affected. Or we will say that the demand function is homogeneous of degree 0. Now, the homogeneity of demand is a direct result of the utility maximization assumption. That is, demand functions derived from utility maximization will be homogeneous. Demand functions derived from utility maximization will be homogeneous. Or if a demand function is not homogeneous, it cannot reflect utility maximization. That is a very important point. Any demand function derived from utility maximization is homogeneous. And if a demand function is not homogeneous, then it will not reflect what is known as utility maximization. Utility maximization. Now, in the example we have discussed, suppose that uxy is equal to x raised to alpha, y raised to beta. Suppose that it is x raised to 0.3, y raised to 0.7. That is normalizing alpha plus beta as equal to 1. The demand functions then x star is equal to 0.3 into I by px. Y star is equal to 0.7 into I by py. Now you can see that these demand functions are homogeneous of degree 0, because if you multiply I with a constant and px with a constant, x star, optimum quantity, is not affected. The same is true with regard to the function, the demand function for y. So these demand functions are derived from utility maximization, and as such these demand functions are homogeneous of degree 0. That is a property of all the proper demand functions. All the demand functions are homogeneous. That is homogeneous of degree 0 in all prices and income. Now, given this, in the next class we will consider the comparative static analysis of a change in income. A change in income, that is consumers' response to a change in income, that we will discuss in the next class.